Hi Geometry, welcome to 4.4, Prove Triangle Congruences by Side, Side, Side. Okay, so this part's important because we are going to be proving triangles with different methods. So side, 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 or SSS, refers to obviously the sides of the triangle, and you'll see an A in there once in a while. That would mean the angle. But in this case, it's only side, side, side. So all three sides must be congruent, and I can use triangle congruence to strengthen structures, such as bridges. All right, so here we go. If you look at these two triangles, I have corresponding single sides. Let's see. They're congruent. These have double slashes. Those two are congruent. These two are congruent. I also have all the angles. But we're going to write a congruence statement. So I don't know if you can see the letters. This is J, this is K, and this is M. So triangle JKM is congruent to. So J has two slashes, so that would go with this letter, and that's letter P. So triangle P. Okay, so K was next. I have one single arc, so that would be O. I don't know if you can see that. That's letter O. And then the last one I didn't put any mark. That would be letter R. I don't know if you can see that. So they must be in the correct order. And one thing I want you to know, if all three sides have corresponding congruences from one triangle to another, then all three angles will also have corresponding congruent angles. So here's our congruent statement. I'm not sure why I put it up there and not down here. And how do you know that angle M is congruent to angle R? Well, if two angles are congruent, then we know the third ones are congruent. Remember the third angles theorem? All right, solve for x. Now recall this one. The exterior angle is equal to the sum of the two remote interior angles. So 2x plus 10 plus 3x is equal to 7x minus 50. That's a 7, okay? Let's combine like terms here. 5x plus 10 is equal to 7x minus 50. I'm going to subtract 5x on both sides. I'm going to add 50 to both sides. So x is equal to 30 degrees. Double check to see if they want you to find the angles. It just says solve for x, so that we're done. If you needed to find the angles, then you would have to substitute in for x. All right, so this one, there is a little activity. I'm sending you home with the different straws. You are going to have to dig up a ruler somewhere in your household, and the first thing you're going to do is cut straws to make the lengths 8, 10, and 12 centimeters. Okay, so if you're not sure which one's centimeters, centimeters are the smaller ones. Okay, thread a string through the straws and make a triangle by connecting the ends. Haha, it's already done. Okay, now use the same length straw, so you got to cut them again to make another triangle. If possible, make it different from the first. Okay. What do you notice? Regardless of what order you make them, they're going to be congruent. Okay. Now, explore 2. Cut straws to make the side lengths 5, 7, 9, and 11. So I'm going to have a quadrilateral. Thread a string through it. Ha, look at that. How about that? Now, make a second one. And this is where my little experiment falls apart because my second quadrilateral is missing somewhere. That means I'm going to hunt Blaze down. He's probably playing with it. In any case, what do you notice? They're not congruent. You can put those straws in different orders and you'll have a different quadrilateral. Okay, so you're going to definitely do this at home. You'll probably have to pause this, and I will give you all the materials and you will bring them in. Thank you. All right, next page. Here we go. Side, side, side postulates. Okay, so you usually don't call it postulates, just say side, side, side. And if, and this is actually really important, this is our first one, because we can be using this to prove other ones, etc., other triangle congruences. Here we go. If 3 sides of one triangle are congruent to 3 sides of the second triangle, then the 2 triangles are congruent. We don't need to know anything about the angles, but these 2 sides correspond, these 2 sides, and these 2 sides. Okay, so you have triangle ABC, triangle DEF, and I always think it's best to look at your triangle congruence statement, because A corresponds to D, B corresponds to E, and C corresponds to F. So if you look at AB, the first 2 letters are congruent to DE, the first 2 letters. And that's how you'll get all of those. So side, 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 you have to show all 3 sides are congruent. And you don't need to show the angles, so because you have side, side, side. If the sides are congruent, you know the angles are congruent. So that means angle A will be congruent to angle D. Pretty cool, huh? Let's see here. Complete the proof. This is where reflexive is going to come into play. Are you ready for this? I am, right here, it's marked with a single line, is congruent to KI. It's supposed to be KE. Okay. Let's see here. MIK, KEM. Yeah, that's supposed to be KE, I believe. And IK, so I've got these switched around. IK is supposed to be congruent to ME. Come, no one noticed that. All right. And IK. That's given. All right, because it's shown by the statement here. So what I'm going to do is I'm going to kind of redraw this a little bit, and I'm going to split them apart. All right. So sorry about that mix-up. I'm surprised I didn't even notice. I didn't have it marked on my original sheet. Okay, so this is all given. So I know 2 sides. And remember, we're trying to prove side, side, side. So what am I missing? I'm missing this side and this side. Well, are those sides congruent? Yes. Why? MK is congruent to MK. So this segment is congruent to this segment. A lot of times people just do this on the original drawing. I like to split them apart. Sometimes that helps you see things. Reflexive. Remember, that's that little rule that you thought was kind of crazy. Like, why would you ever have to list something twice? There you go. Now, is triangle MIK congruent to triangle KEM? Yes, by side, side, side. That's it. And a lot of them aren't going to be that easy. Okay. Next one. Okay, this one is going to... There's a lot going on here. Okay, so which are the coordinates of the vertices of a triangle congruent to XYZ? Okay, so, well, here we go. What I did was I took every set of ordered pairs, I drew them out, and try to see if they were the same as this one. So, for instance, here I counted up 1, 2, 3, 4, 5. Uh-oh. 1, 2, 3, 4, 5, 6, sorry. And then 1, 2, 3, 4, 5, 6, 7. Okay, and then I'm going to help you out. Using Pythagorean theorem, this is going to turn out to be square root of 85. Glad I'm helping you out with that. Okay, so I'm going to give you these little tiny graph papers, or you can put it on a whole graph sheet, and it's really up to you. I'm going to go ahead and find these vertices. So 6, 2. 1, 2, 3, 4, 5, 6, 2. And then I have 0, negative 6, 2, 4, 6. And then I have 6, negative 5. Let's see here. 1, 2, 3, 4, 5. Okay, so this length right here is 7. This length we have to do a little Pythagorean theorem. You can do Pythagorean theorem or you can use distance formula. I'm going to help you out. You get about 6.08. And then this one, I'm going to help you out, turns out to be 10. And this is for A. So obviously that's not the same. Let's do another one. Okay, 5, 1. 2, 4, 5. Oh, 5, 1 right there. Negative 1, negative 6. 2, 4, 6. And then 5, negative 6. Makes a little bit more sense because it's a right triangle. All right, let's find this distance. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. And yes, this is going to be square root of 85. So the answer is B. But I'm going to ask you to go ahead and find the other two and to kind of let you know if you're on the right track. C, you get 7, 5, and then 8.6. And then D, you get 7, 6.08, and 8.485. So double check those. Okay, the next construction we will hopefully practice this in class. In the past, I would just put it on a Part V video, but I'm feeling lazy today, so here we go. Copy a triangle. So the first thing you do is take your straight edge and make a long line. Then you're going to find out how long this bottom length is. Okay, also, if you have one of these cheap compasses, you can tighten it up. This was really loose and I tightened it up. I've had this for years. I never figured that out until now. All right, so I want to find out this length. I'm going to mark it right there. Okay? Then you're going to find out this length right here. Put the arc here. There's the arc. Okay? And last but not least, find out this length on the far right side. It's a little smaller there. Mark the arc. Mark the arc. That is going to be your point. Your third vertice. Connect the lines. There you go. It's pretty easy. Okay? And how did we do it? Let's think about this. First I found this side. Oh, I want to put an S. Okay? And then I measured out this side. Okay? And then I measured out this side. So what did I do? Side, side, side. So we did a proof using the information that we know. Last but not least, here we go. The opposite sides of the gate are the same length. How would you put a brace on this gate to be sure that the gate keeps its shape? Because after a while, okay, this is supposed to be wood, it's kind of hard to see, but after a while it'll start kind of get rickety and stuff. Well, guess what? All you need is a triangle in there. Why? Okay, well, as soon as you put a triangle in it, it forms two triangles with fixed side lengths. It's kind of that idea right here. If we have a four-sided figure, this will kind of jiggle around a little bit, but this is a fixed shape. It's not going anywhere. So if you make two triangles, you have fixed side lengths. Of course, you could make the diagonal this way if you want, and you'll see some barn doors that'll have both of them, just to double check. All right, here's our homework assignment, and here's our Common Core Standard. Everyone, have a nice evening. Stay dry.